Hello. Algebra students, Mr. Lawrence here, and we're going to do a real quick video on domain and range and functions and relations and mapping. Now, before we can talk about if it's a function or relation, we have to be able to find the domain and the range. Remember, domain are your x values, right? So you see this little set of ordered pairs right here. We've got several x's and several y's. Well, the domain is just simply the x values. We've got 2, we've got 3, and we've got 4. If one had repeated, I would not list it again, and I like to list them from least to greatest. Now my range is going to be 3, 4, and 5, right? There you go. All right, so domain for number 2 is 2 and 3. The range for number 2 is 3, 4, and 5. Now, is it a function? Is one a function? We haven't talked about it yet. I want you to think of the x's as people. Okay, so maybe this x here is Tom, and this is Sue, and this is Frank. Okay, and I want you to think of the numbers as restaurants. So you know this one's McDonald's, this one's Olive Garden, and this one's Red Lobster. Okay. Well, in this matching here, I have Tom going to McDonald's. In fact, you could do a mapping. Remember, Sam, you were asking me about a mapping. I'll do a mapping right now. Okay, here's a mapping. There's my domain. And so I need Tom. And the range, Tom is going to McDonald's, right? And then I have Sue. Sue is right there. And Sue is going to the Olive Garden. And finally, I have Frank. And Frank is going to Red Lobster. That's cool. That works, doesn't it? That's a function. Okay. It is possible for, excuse me, for 3 different people to go to 3 different restaurants at the same time. All right. Now I'm just curious, what happens if I change this 3 here to a 4? I'm going to change it to a 4. Okay. So that would change my domain, right? I need a smaller eraser. I've got the bigger one on. There we go. That's a lot better. And so now I can close my mapping circle here, my oval. And I need 2, or who is that? Is that Tom? Oh no, I took the wrong thing out. Excuse me. I don't want to get rid of that. I want to keep 3 in here. Yeah, and got to change the place where Tom is going. My mistake. Sorry about that. All right, so I'm going to change the place where Tom is going. And so now my mapping is going to look like this. 2 is going to 4, and 3 is going to 4, right? Is it possible for Tom to go to the Olive Garden and Sue to go to the Olive Garden at the same time? Sure it is. It's still a function. All right, we're going to look at some more examples. Don't worry about it. If you're confused right now, excuse me, we will, lots of crazy noises here. Hold on a second. All right, so here we go. Let's do number 2. Got the domain and range, okay. And I'm thinking about the people, and I like to see the mapping as much as possible. Okay, so here's my domain. My domain is just 2 and 3. And then my range is 3, 4, and 5. Okay, now remember, I'm going to think of the domain as people. So in this problem, I have Tom going to the Olive Garden, and I also have Tom going to McDonald's, and I have Sue going to Burger King. Hey, wait a minute. How can Tom go to 2 different restaurants at the same time? He can't. This is not a function. This is called only a relation. It's not a function. It's not functional. Tom can't split himself and be at two places at the same time. Think of the domain as people, the range as places. All right. Over here we have mapping. They want us to tell the domain and range. And let me tell you where everybody's going first of all. Okay. So our domain in this case is right here, 1, -1, and 3. Our range is 5, 7. All right, remember, these are people. Tom's going to McDonald's. Sue's going to McDonald's. Frank's going to Burger King. That's okay, right? Tom and Sue could meet at McDonald's. They don't even have to meet there. They could just be there at the same time coincidentally, right? So this is a function. This is a function. All right, over here, I need to give you the information. Let's do this. Let's do this. Yeah, let's do that. Okay. On this one, I've got Tom going to McDonald's. I've got Sue going to Burger King and to Wendy's all at the same time. Hey, that doesn't make any sense. How can Sue be at Burger King and Wendy's at the same time? This is not a function. It is only a relation. Okay, now it depends on the type of question they ask you. You might say not a function, or you might say only a relation. I like this answer better, but if this says, decide which of these are functions, or is this a function, you could say, no, it's not a function. Okay, a best answer would say, oh, it's only a relation. Now, here I have some graphs here. Please ignore the yellow line for a minute, but I have some lines and curves, and we're going to see if they're functions or not. There's a real easy way to tell, and I've shown you this before, is to use a vertical line. If this vertical line hits the graph in more than one place, then it's not a function. It's called the vertical line test. So let's look down at this purple one first. Whoa, what just happened there? There we go. All right, look at the purple one. You should know it's an exponential curve, right? We just did those. You should know there's an asymptote. No, I didn't just call you a bad word. That's an asymptote, right? There's an asymptote right here. Yeah, it looks like y equals -1, right? Okay, let's only look at the purple one. And let's take my vertical line and see if I'm going to intersect that purple curve in more than one place. No, I'm not. Oh, by the way, what's the domain of the purple one? Let's see if we can do domain and range while at this. The domain. What are all the possible x values? Well, x could be really large positives, couldn't it? It could be really small negatives. The domain is going to be all real numbers. Yeah. Now the range, be all the possible y values. Y cannot be really large numbers. In fact, y can't go past this asymptote, can it? So we're going to say it's all real numbers such that y, and is y allowed to be -1? No, so y is going to have to be less than -1. And there you go, right? Because the largest value we can get is almost -1. This will approach the asymptote, y equals -1, but it'll never get there. All right, let's try the turquoise one. Let's do the domain and range first of all. And let me see, I don't know if I have the same color, I guess that's close. All right, the domain. Well, remember that parabola is going to keep expanding, right? It's going to keep expanding. So the domain is going to be all real numbers. Some of you are thinking, hey, the domain's always all real numbers. No, it is not. Okay. The range looks like there's a minimum value here at the vertex. Looks like y is 0 there, right? Because I'm on the x-axis. And so y can be anything from here up. So my range is going to be all real numbers such that y some greater than 0. Can y be equal to 0? Well, sure, it's touching the x-axis. Y is greater than or equal to 0. Now, is it a function? Well, I'm going to take my vertical line and I'm going to move it along there. I'm going to see, am I hitting that curve in more than one place? And I don't believe I'm going to. So this is a function as well. All right, let's try the orange one now. The orange one. All right, the domain of the orange one. Remember how some of you thought the domain was always all real numbers? Look at this one. X can be a negative number Not all negatives, though. X can't be 0. X can't be positives. So the domain of this orange one is all real numbers such that X is less than or equal to, and it looks like it's touching right there, -2. Okay. The range, well, this parabola is going to expand forever. It's eventually going to get really wide in both directions. So the range in this case is going to be all real numbers. But they're not always the same. All right. Let's see if it's a function. Ooh, look at that. Look at that. My vertical line is touching the parabola here and here. Or you could argue 2 more places here. This is not a function. If we listed out those values, we'd have a number. Here, let's put it on an integer. Okay? We would have this number here, which is what, -4, I think, right? -4. And it's going to 2 different restaurants at the same time. All right. The olive one, the domain is going to be all real numbers, and the range is going to be all real numbers. That line is going to go forever. Is it a function? Let's get my vertical line. Yeah, I don't think I'm going to hit it more than once. There we go. All real numbers for domain, all real numbers for range, and it is a function. Finally, this peach-colored one. We better do the domain and range of this one. The domain, 1, 2, 3, 4, 5, 6, is -6. That's it, -6. Look, x can't be anything else. That's the linear equation would be x equals -6, right? That's the only thing x is allowed to be. All right, the range. The range. Well, it looks like y can be really large positives. It can be 0. It can be really small negatives. The range is going to be all real numbers. Now, is it a function? Well, let's get our vertical line. Oop, it looks like I'm intersecting that thing everywhere. Let me send him to the back, and that way you can see. There we go. You can see the orange one and the peach one, or whatever color that is, yellow one and the orange one are touching everywhere. So this is not a function. It's only a relation. All right, very good. That was all review. By the way, once again, this is a mapping right here. So Sam Wilson had sent me an email about mapping, and we're going to talk about it in class before you see this video, but good to hear it again. This is what the mapping looks like. Okay? All right, Mr. Lawrence signing off. Have a good night, everybody.